Hello and welcome to another update about the Game Dangerous project. So in this video I'm going to try and give you a very compressed summary of where the project currently stands and the last two major updates I've done to it, which are likely going to be some of the last updates I actually ever make to the code base, apart from fixing any bugs which are yet to be found. So just what you're now looking at is the game itself running. So what I'm going to show you first is just a look around the gem mining map 1, which I've been working on for a little while now, basically to show you how the lighting works in the engine currently. So this has been updated fairly recently. I'm just going to skip through this dialogue fairly quickly, but I'll come back and explain this in a bit more detail later. So up to relatively recently there was no concept of shadow casting lights within the game engine. All light just basically travel through everything, which obviously isn't particularly realistic. It's something that I didn't, for a long time I didn't think I actually was going to improve upon, because I thought it would be too difficult given the time constraints I'm allowing myself to actually get working to a decent standard, but I've managed to come up with some kind of a custom solution, which I'm not going to go into the details of how it actually works in this video because that would be a bit beyond the scope of it, but yeah, I guess you can see like it does lead to some slightly curious looking but also rather soft shadows. I'm just going to give a little tour around this map here. So yeah, like, ooh, here we are. Most of my time making this work was actually working on the shaders in GL shading language. That did involve some changes to the engine too. Okay, so I have done a post on the repository homepage about this on GitHub, and there's a link there to a Reddit post I made about how the lighting actually works, which itself is a fairly compressed explanation of how it actually works. But yeah, that is that. So oops, going to move on to the talking about the second update now, which is the most recent thing I did. And that is related to the scripting language, which drives all kind of interactive and real-time behaviour, you could say, in the game engine. So you probably noticed as I was moving through that map there that there were a few interactive features, such as the menus with options that appeared, the dialogue that I skipped through fairly quickly, even the lighting that you see is itself actually run by through the scripting language. So like lights are actually rendered like on a per game logic tick basis. So I'm not going to go again. I'm not going to go into any like serious detail about how this scripting language works. It is documented to some extent on the repository homepage, but what I will say is what you can see here in VS Code is two of the scripts written in this language, which are featured in the map I've just shown you. The language is called GPLC, or Game Programmable Logic Controller, and very briefly, the top section you can see here is the variables and constants in the language in each particular script, and below this little tilde here there's what I call the code block, which is the keywords or alternatively opcodes that can each cause a change to each of these values, each game logic tick, and also change other values within the scope of the game engine. So one of the issues that I ran into when developing this is that I needed a way to debug what was going on inside the virtual machine that actually runs this scripting language as the game is running, so I could try and understand what's causing crashes when they happen in real time. So how did I do that? Well, again, I'm not going to go into like much detail about the actual code behind the scenes here, but what I will say is I went for a few different approaches as to how to do this, and something I've only come to relatively recently is how to actually include the names, the symbolic names of these variables in the debugging output. So for quite some time the debugging output that you would see from the engine would be devoid of these, so you would just see like a list of numbers, each of which referred to essentially an index number into this list of different variables, which obviously is pretty kind of fiddly to try and get your head around when you're looking at it. So the challenge was, well, how to sensibly get the actual names of the symbols into the engine so I could see them in the debugging output. So the change I made most recently to actually do that, which improved upon a previous approach I'd used, is in the server, which is, so the server is what this web client that you're looking at, this web application written in TypeScript, actually accesses. So you can see the server running here in this console window. So when I start it now, it actually produces a lot more output than it used to prior to this most recent update, which will explain why that is in a minute. So this is the server or backend running locally on this Linux machine. This is the web-based client. So the server is serving to the client a view of what the actual map that we were just playing around in the engine looks like. So you can look at one vertical level at a time here, and as well as seeing the structure of the map, you can also look at the code inside each of these GPLC scripts within the map. So I'm going to focus on two in particular. There's this one here called AI Conversation 1, which is, it wasn't developed using AI, by the way, this refers to an aspect within the story of the game. Within the server you can see essentially the same code that you can see here in the editor. This is only implicitly reverse compiled. It's not literally reverse compiled. So there's another script here called door controller. So this script here is responsible for what drives the little dialogue interaction that you saw previously. That's still need to pad out with some more kind of expressive modelling. This controls this opening and closing door that you briefly saw me use there. So the way I've actually gone about getting the names of these symbols into the engine so you can see debugging output in real time is by modifying the server so that it outputs this output. So you can see what you see in here is, as it goes through each of the scripts featured in this map, it outputs what I call the symbol debugging outputs, which again I'm not going to go into too much detail about how this system actually works. It is very cumbersome, I'll admit. Like, there's a lot of actual text here, but it is not really designed to be human readable as such, so that's not too much worry for me at this point. I'm going to go down to the bottom to the the two scripts that I'm actually going to be looking at. So they are AI conversation 1, and door controller. So just take a step back a minute here. So up until recently, the config file for the engine that was used to input the various configuration parameters was just some kind of custom text file format. Fairly recently I've changed this to using a JSON format, and I use the Haskell library ASON to import this, which has some of its own advantages. But how I've leveraged this a bit more is I can take the output from the server, this debugging output, which itself is in a JSON format, JSON arrays specifically, JSON arrays of strings, and put it into these two parameters here, debug set and debug symbols. So the debug set property contains the names of the two programs that I want to debug. Debug symbols is this, debug symbols output I was just referring to. Verbose mode here specifies that I want some debugging output from the engine and I want it to be filtered to these two specific programs and use this debug symbols output. So I'll just briefly talk about what this program actually does. AI conversation 1. So it's related to this dialogue scene just we're going through, that I'll go through again in a minute. Essentially, it implements what you might call a dialogue graph. It's been seen in like many kind of role-playing games over the years. So basically, when you interact with a character, you'll start at a particular root node in the dialogue, and depending on what dialogue options or responses you select as the player, you'll go to a different node in the dialogue tree. And there are only so almost all of these symbols here are like constants effectively, they're never actually changed. The scripting language itself doesn't support like constants as a concept, so all of these could potentially change, but they don't change in reality. The only value out of all these that changes is this one called switch at the bottom. But there is another value that changes within the code block itself, which is this value called branch table here. As to why it's in the middle of the code block and not in the data block with the rest of these variables, that's a bit of a longer story. It's related to the way that this language doesn't even support arrays properly. It has to be simulated, but in any case, this is the other value within the program that changes between each game logic tick, and specifically branch table changes each time you move to a different dialog option. So where are we? Oops. Okay. Game manager's still running. Okay, so I'm going to go back through this door. Oops. Okay, I've got to the secondary spawn points. And I'm going to interact with this object, or this script again. Okay, we get this little cutscene. So as you can see, I've got 3 dialogue options here to start with. Okay, so I'm going to say yes, thanks. Why has the general alarm been raised? Right, and then I'm going to go to the debugging output from the engine. Right, where are we? Let's go up to now I have to try and work out where I actually started in this session. It's going to be interesting. No, I'm much further down. Right. So here we are. Yeah, okay. So this is where the engine started again. We started in the map, and okay, this is where I first interacted with this program. Play start GPLC program AO conversation 1. Okay, so this is the debugging output. I'm talking about branch table star. Is this value that is essentially pointed to the node in the dialog tree that the script is currently, or the program is currently at. So it starts at 36, as you can see here. Why 36? Again, too much to go into why 36 specifically, but yeah, that is a pointer to the root node in this dialog table. It's still 36 on the next tick here, and the next tick here. There is a reason for that, but as you can see, it's changed to 37 here, still 37 here, and it's now 40 here. So we are progressing, representing the fact that we're progressing through this dialog tree. So if I now take another option here, there's been some more debugging output, and as you can see, script runs again on the next tick, and we've got to 42 in the dialog table here. So yeah, that's a very kind of rough approximation, like gives you a very rough idea of how that works and what the motivation for it actually is. Once I've interacted with that program, it then opens it, this door opens, I can go through here, it closes on me again, I bump into it, and oh, it opens again, I can go through it, it closes again, I touch this again, it opens again. Yeah, I'm not soft locked. Brilliant. Okay, so thanks for tuning into this video. Appreciate it if you got to the end. As you can probably imagine, this was unscripted and recorded at the end of quite a long day, but I hope it's given you some idea of where I'm at with this project. It's kind of like reached a stage where I feel like I'm just working on the very last few kind of quality of life improvements, and from this stage on, it's pretty much just going to be bug fixes when I come across bugs as I'm developing the remainder of this map set. So yeah, thanks for tuning in. Appreciate your time, everyone, and I'll see you on the next one.